So children, this is the second problem of our discussion today. So you can see that they have given a block that is 0.5 kg slides from the point A on a horizontal track with a speed of 3 meter per second towards a weightless spring of length 1 meter. So this spring, you can say this is the length of the spring to be basically 1 meter. So they have already given this. And the part AB, that means part A to B, this part they are talking, that is a frictionless surface. So I'll write just over here, AB is a frictionless surface. So AB is a frictionless surface, right? So AB is frictionless. And the track of the part BC has coefficient of static friction and kinetic friction as 0.22. So they have mentioned one thing, that AB and BD are 2 meter and 2.1 meter, 1.4 meter. So you have seen that, children, I have already taken. This is 2 meter and this is 2.14 meter. Another important thing is that the part B to C is basically frictional surface. Now the question is that which particular coefficient of friction we should take. Either we can take coefficient of static friction, which is given to be 0.22, and the kinetic friction is given to be 0.2. But since the block will be sliding over this surface, according to the question, so we must take the coefficient of kinetic friction, that is equals to 0.2. So they have asked you, children, find the total distance through which the block moves before coming to rest. So this is our question. So in this case, you have seen this body is actually 0.5. Now, one thing you have to ask, when you have to understand, that initial velocity of the block was 3 meter per second square. So that means if I just start with the sum like this, initial kinetic energy of the block will be equal to then what? Initial kinetic energy of the block is equals to half m u square. So that is equals to half m is 0.5 and u square means that is equals to 3 square. So you just calculate this. So this will come to as 2.25 joules. So that means one thing you should understand, children, when the block has set off for this journey from A to the spring, the energy the block had was 2.25 joules. So that is the most important part. Now, one thing you have to understand, case 1 or point 1, that is as the block is moving from A to B, since it is frictionless, so one thing you have to understand, there is no loss of energy. There is no loss of energy. This is the first part. The second, you have to understand, when the block is moving from B to D, that means just before this, it is actually, you can say that before it is just hitting the spring like this. Say suppose before it is compressing the spring or it is in contact with the spring, something like this. So as it is moving from B to D, so what will happen? You have to understand that there will be a loss of energy due to friction. So as the block is moving from B to D, okay, energy is lost due to friction. So that means what I can say, that energy, because frictional force will be equal to what? The frictional force on this particular block, if I just take it, so this frictional force will be acting in the opposite direction, something like this, because the movement of the block is in this direction. And that frictional force will be equals to mu into m into g, if m I consider the mass of the block. So therefore, I can say over here that since the block there will be loss due to the frictional force I told you. So we can have to find the frictional force, right? So what is the frictional force? So frictional force will be equal to, therefore, frictional force Ff will be equal to mu into m into g. And mu is how much we have taken, because we have taken the kinetic friction. So that will be equal to 0.2 into m. What is mass m? Mass m is equals to, we have already taken 0.5. And what is g? They have already asked us to take the g to be 10. So that means frictional force applied on the block or experienced by the block will be 0.2 into 0.5 into 10. So that will be coming to as how much? That will be coming to as 1 Newton. Hence, energy spent on frictional force, on overcoming the frictional force. So that will be equals to how much? That will be equals to force into distance of BD, frictional force into the distance traveled while covering BD. So that will be equals to, therefore, 1, and frictional force is how much? Sorry, the distance is how much? 2.14. So that will be equals to 2.14 joules. So that means in order to move from B to D, the block has lost this amount of energy. Now the remaining energy will be used up in compressing the spring. So that means compressing the spring means it will compress the spring. Suppose this spring is compressed to a distance of suppose x. So if I consider like this, that means the spring is suppose being compressed to a distance of suppose x. So the spring will be looking something like this after it is compressed. And this is the distance to which the spring is being compressed. So let the distance be, say, d to d dash, okay, is the distance moved during this compression. So can't I say, children, that means in this particular part, when it is compressing the spring, here the spring potential energy will be spent, that is half kx square. Another energy will be spent, that is the frictional force, that is because this particular part is also having a friction. So we can also write this will be equal to frictional force into x. So this is the total energy spent by this particular block when it is compressing the spring by a distance x. So let me just move into the last step over here. So we can say the third part which we will take, that energy spent by the block, energy spent by the block in moving from D to D dash, D to D dash, and that will be equals to what? That will be equals to the compressing the spring half kx square plus the frictional force into x. And what is the value of this k they have given? The value of k they have given as the spring constant they have given as 2. So this would be half 2 into x square plus frictional force we have already found out 1 into x. So you get this amount is x square plus x. So this is the energy spent in just moving the block from D to D dash. So children, what can we say, children? That the block has started its journey with an energy of 2.25. This energy is spent first of all in moving from B to D, and that we have already found out, that is equals to 2.14. And the remaining is used up in overcoming the friction and the potential energy in order to compress the spring. So therefore this will be equals to x square plus the x part. Am I clear to everybody? So this is the total energy spent. So what do you get, children? We get an equation x square plus x is equal to 0.11. So we can write x square plus x minus 0.11 equal to 0. So we can just find out this thing over here by using Siddharacharya formula. That will be minus 1 plus 1 root over of 1 minus of 4 into minus 0.11 whole divided by 2. So from here what you get? you get x equal to minus 1 plus minus root over of 1.44 divided by 2. So from here x equals to minus 1 plus minus root over of 1.44 means that is equals to 1.2. So this will be equals to, therefore it will be root over of 1.44, that is 1.2 divided by. So x is equals to minus 1 plus 1.2 divided by 2. So this will be equals to, x will be equals to 0.1. If you take the negative sign, x equals to, it will become minus 1 minus 1.2 by 2, x equals to minus 1.1, which is not possible. So this value will not take, we'll take only this value. Here x means basically what, children? If you carefully look into this, x will be equals to what? This portion is called x. That means d dash. So what is the total distance moved by the block? First of all, it has moved from A to B, then it has moved from B to D, then it has moved from D to D dash. So I can write what, children? The total distance will be therefore AB plus BD plus DD dash. So let me just write down in the over here. So they have given you to find the total distance covered by the block during compression. So I can write, therefore total distance moved by the block will be equal to, by the block before it stops, before it stops, that is equals to, before it stops, that is equals to AB plus BD plus DD dash. AB is how much? AB was equal to 2 meters, right? AB was equals to, they have already given 2 meter. BD is how much they have given? 2.12. And DD dash we have found out 0.1. So total distance, therefore, if we calculate, so that will be equals to how much, children? The total distance, therefore, we will be getting as, that is equals to, if you just calculate it, that was 2.14. So this is 2.14. So the total distance will be equals to 4.24 meters. So this is the total distance moved by the block before it comes to rest. So this is our very, very important question we have done. I think